Now we are going to revise the unit of force and pressure. From this unit we conducted our first term exam and then also we conducted some unit exam. Now once again we are going to discuss about that unit. First of all, you should answer this question: what makes an object slow down? What makes an object slow down or go faster? Or change direction. Try to give answer to this question. What makes an object to slow down, or what can do a body moving, we want to make it faster, or a body which is moving, we want to change its direction. For this all, what can do these changes? Now another question: what do you do to make a football to move? Suppose you want to make a football to move. To move a football, what make it? Another question: what do you do to make a moving football move faster? Suppose a football is moving and it moves slowly, we want to make it faster. For that, what we can do? Then, how does the goalkeeper stop a ball? Suppose a fast moving ball is approaching to a goalkeeper. He wants to stop it. What he wants to do? Then, another question: how do fielders stop a ball hit by batsman? Suppose a cricket ball is hit by a batsman. Then the fielders want to stop it. What they do? Another one: how a hockey player changes the direction of the moving ball. That means to change the direction of the moving ball, he give a flick to the ball. In this all case, see, to slow down a moving body, to move it faster a moving body, or to change the direction of a moving body. Also, to move a football at first, or to move a football which is moving and we want to make it faster, and the fielders to stop a cricket ball which hit by a batsman, and to change the direction of a hockey ball. In this all case, how or what they apply? In these all cases, they apply a force. Here are they apply what? They apply force. Because the action of force that changes, what are the things that force slow down or go faster or change the direction or move a football which is at rest or to change the speed of a football that is moving slowly, or to change the direction of a cricket ball or hockey ball. In this all case, what they apply here all a force is applied. Here all a force is applied, or the force that changes these all. Now, if this all case, if in these all cases a force is applied, then what is a force? What is actually force? Try to give answer to this question. What is actually force? Another question. What it can do to bodies on which it is applied? Suppose you want to give answer to this question, what is a force? Or another question is that what a force can do when it is applied on a body. Suppose we apply force on a body, what that can do on that body. Another question is what actually do the actions like shutting, kicking, hitting, lifting, flicking, pushing, pulling on a body. What actually do the actions like shutting, kicking, hitting, what actually do this? Here are actually shutting or kicking or hitting or pushing or flicking. Here are actually doing or applying a force. Here are actually what we do. We are applying a force in these all cases. Okay, here are we applied a force. That is actually happening in these all cases. Suppose when we shut, there is an action which is change the direction of motion of the body. When we kick, what happens? If the body is at rest, that move. Hitting, there is some change in its motion. Pushing or flicking, here also what actually changes the, here when we flick a hockey ball, its direction changes. Here pushing, what actually do? Here the motion starts or change the direction of motion. So in this action, in this all case, there is certain kind of change in its motion. In this all case, there is certain kind of changes in motion. When there is a changes in motion, when we shut, suppose a door, when kick a football, when hit with a bat, when push a dog, flick a hockey ball. In this all case, what actually happening? There is happening something. There is a change in motion in this case. Now, another question you want to give answer. What is actually a push or pull in science? In science, what actually means a push or pull? Can you remember? What actually a push or pull in science? Try Try to give answer to this. Actually, a push or pull means what it is actually a force. A push or pull means actually a force. That is actually there. Now, another question to you. Identify in the following cases as pushing, pulling, or hitting, or both. Once again, identify the following cases as a pushing, or pulling, or hitting, or anything happening together. See, these are the some examples here given. You want to try to find. First of all, suppose a moving a book placed on a table. Suppose a book placed on a table is moving, but actually there is a pushing. Because of that book is moving. Opening or shutting a door. Suppose we are opening or shutting a door, but we want push to open or pull, pushing or pulling. Drawing a bucket of water from a well. To draw water from a well, we want pull. There is, with the help of pull means it is a force. A football player taking a penalty kick. What actually he do? That means kicking. And another one is a cricket ball is hit by a batsman. That is hitting. Hitting means a kind of push. Then moving a loaded cart. Suppose we want to move a loaded cart, we want to push it. Opening a drawer by pulling. So, in this case, we apply sometimes push, sometimes pull, sometimes push and pull together. So, in science, actually, a force is applied there. A force is a push or pull. And that push or pull can change here speed of the body or direction of the body or rest of the body. That means a body at rest, sometimes when we apply a push, that may move. And also by applying a force, sometimes it's a speed increase. And sometimes speed decrease. So actually what is force? It is a push or pull in its simplest way. Now another question to you. What is actually a push or pull in science? In science, a push or pull means a force. Next question, motion imparted on objects due to the action of. That means to move an object, what we want to apply a force. So, motion imparted on object due to the action of force. Now, another question, try to give answer for this one. When does a force come into play? When there is force come into play. A force come into play when there is an interaction between two bodies. When there is an interaction between two bodies, then only there is a force is come into play. Without the interaction of one body over another or one body on another, then we cannot say a force is active. For example, suppose two children pushing a car. That car may move. So there is an interaction between the children and the car. So there is an interaction between two bodies. To a force acting or to force come into play or to force it originate, there must be an interaction between two bodies. Here in the case, pushing what is a car and also pushing two girls each other. Pushing a car. There is an interaction between boy and car. Another one is pushing two girls each other. There is also an interaction between two objects. And also there is another example, there is pulling two girls pulling each other. There is also an interaction. Another example, in a tug of war. In a tug of war, the two teams exerting force. There is also interaction between two objects. Another, a boy pulling a car. There is also interaction between boy and the car. So, a force is to come into play when there is an interaction between two bodies. When there is an interaction between two bodies, then only there is a force existing. Now, actually, what is force? It is an interaction of one object on the other. That may act in the form of push, pull, hit, flick in this way. Next, when we add the forces. When we add the forces. When we add the forces, suppose a table pushed by two children. Two boys push this table in the same direction. That means here the number of forces acting in the same direction. Then the force we add. So when we add force means when two forces acts or two or more forces acts in the same direction, then we add the force. If we can add force when we take the difference of the force. See, when we take the difference of force, see, suppose in a table, one boy pushing from this side and another boy pushing from this side. Here two forces acting not in the same direction. Here the forces are in the opposite direction. So the resultant force or the net force acting here we take as the difference. Here the forces are acting not in the same direction but they are in the opposite, so we take the difference of the forces as the net force, and in which direction that net force is acting, in that direction that the table move. So we can add forces and also we can take a differences of forces when they are taking. If the forces are in the same direction, then we add the forces together, and if they acting in the opposite, then they take the difference. Now another question to you. See how we express strength of a force. Here when we discussed about difference of forces, in one side the table moves. In which side the force is greater? In which side the force is greater, on that side that table move. So the strength of the force is measured in terms of its magnitude. So strength of the force is measured. Strength of the force is measured in terms of what? Magnitude. In terms of magnitude. But there is direction also. That means in which direction that the force is greater, in that direction that the force is acting. So force, that is a vector quantity. It has both magnitude and direction. Now we discussed about force, how we can add it, and also when we take its difference, and how we can measure the strength of a force. Now another question to you. When a number of forces acts on an object, then how we find the effect of the force? Suppose here the number of force acts on this. In this side also there is one force. Suppose here also one force. Then how we find effect of that forces? How we find the effect of these forces? We find the effect of these forces by the net force acting on it. Net force. In terms of net force, we take the effect of force on this object. That is the method we use there. Once again, question: when a number of forces acts on an object, then how we find the effect of the forces? We find the effect of the forces as the net force acting on it. Now try to give answer to this question. What happens when a number of force acts on an object? Suppose what happens when number of forces acts on an object? The object may move in the direction in which the net force acts. The object may move in the direction in which the net force acts. That is actually happening. Now another question to you. What happens when a force acts on an object? Suppose a force is acting on an object. What happens? Can you say? That is, when a force acts on an object, what are the things force can do? Force can change what is the rest to motion, or force can change, that means the speed. What are the things? Force can change direction. So force can change a body which is at rest to motion. Force can change the speed, that means a moving body. If we apply a force in the direction of its motion, then its speed increases. Suppose if we apply a force opposite to the direction of its motion, then its speed decreases. So force can change the speed. Then, for example, a cricket ball. A batsman hit it. Then what happens? Its a direction changes. So force can change direction also. These are the things a force can do. What are the things? It can change motion, speed, direction. Now we want to check. Can a force change the shape of an object? Shape and size of an object. Can a force change shape and size of an object? For example, when we compress a spring, what happens? Its size changes. And if we compress a sponge, then what happens? When we pressing a sponge, its shape is changing. So force can also change what? Shape and size of an object. Force not only do a body from rest to motion, change its speed, change its direction, it also can change shape and size of the object. It also can change the shape and size of the objects. So force can do these all things. Now, what do you mean by change in state of motion? What do you mean by change in state of motion? Suppose a body at rest, by the application of a force, speed change. Sometimes it's a direction change. Change in the speed or direction of motion may stay as a state of motion. What is actually this thing? Change in state of motion. Change in state of motion means change in the speed or direction of motion is called what is actually change in state of motion. Once again, change in state of motion means change in the what speed or direction of motion we termed as a change in in state of motion. But actually, what is the change in state of motion? Here again, one more things you want to remember. What is the state of motion? That means a rest or motion of a body. We can say as it's a state of motion. Suppose a body is at rest, then its state of motion is rest. And if a body under motion, then its motion is then its state of motion is moving. Here you want to remember two terms: change in state of motion and state of motion. Now, another question to you: does the application of force always change state of motion? This is the question. Does the application of force always change in the state of motion? We know what is actually state of motion. Change in the speed or direction of motion. Suppose we are applying a force. Can that force change state of motion? In some cases it is possible. Suppose in a heavy box or a wall, we apply force. Is there any change in its motion? When we apply a force on a heavy box or on a wall, does it move? Does it move? No. So, by the application of force, always not produce change in state of motion. Application of force always may not produce change in state of motion. In some case it happen, but in some other case it is not happen. Now another question to you: can force change the shape of an object? What is its answer? Now you can say its answer very clearly. Can force change the shape of an object? Yes or no? Answer is yes. You know already its examples. Now another question: what happens when we apply force on an inflated balloon by pressing it? Take an inflated balloon and we press it. What happens? Give its answer. When we apply, that means force means we are pressing. What happens when we apply that force? The shape of that inflated balloon changes. Shape of the inflated balloon changes, and also its size also changes. Now another question to you. So when we apply force, both the shape and size of an object change. Give an example for it. Give an example for the change in shape and size of an object when we apply force. For example, when we press an inflated balloon, with our hand, then what happened? Its size decrease and also there is a change in force. Now another question too. What are the things that a force can do? What are the things that a force can do? What are the things a force can do? Force can move a body from its rest. Another, force can increase or decrease the speed of a moving body. Force can change the direction of a body. Force can change the direction of a moving body. Then, what other things force can do? Force can change the shape or size of a body. So, these are the things that a force can do. We know what is actually force in science. In science, force means it is a push or pull. What it can do? It can do the things we discussed just before. What are the things can move a body from its rest, change its speed when it is moving, and can change its direction, can change shape and size of a moving body. Now, another one term, contact force, that we discussed. Give an example for contact force. Here we are doing revision, so you should remember these are things. What is actually a contact force? We can apply force. Suppose you are trying to push a table from some distance from the table without touching it. Can the table move? When you are not touching on the table, can you apply force on it? Can you apply force on it? No. So, that there is not any contact. If you want to move the table, then what you want to do? You want touch. You want to touch on the table, then apply force. And such type of force is called contact force. A force that we can apply with the contact of the body, and that force is called contact force. Then the table moves. How that force applied from our, that means the force is arising from our body, and it is the muscular force. It is the muscular force. Example for another contact force, pulling or pushing a trolley. Then we apply force by touching it. Another example, what is kicking a ball? There also with the contact we apply force. But in some other cases, there is force acting without contact. For example, a magnet attracts a nail. A magnet can attract a nail, but there is no contact. And such a force is called what is non-contact force. What it is called? Non-contact force. A force that exerting on a body without the actual contact between them. Example, magnetic force. Another one is a gravitational force. Suppose a coconut falling from a coconut tree. It is due to gravitational force. It is due to the gravitational force. There is no contact. So, force can be contact and non-contact. Force can be contact and non-contact. In that way, we can classify forces as contact forces and non-contact forces. Today we discuss about different types of forces that we already discussed in our regular class. In the revision, we discuss about what is actually force, what are the things a force can do, what is a contact force, what is a non-contact force, example for contact and non-contact force. These are all things given to you. Remember that you already studied in our previous class. So with this all, we can wind up today's class. Thank you.